Hello, I'm Sean Tailford. The use of ergogenic aids in the sporting world currently is a hotly debated topic. The purpose of this presentation is to display the effect of sodium bicarbonate ergogenic aid can have on an athlete. By definition, an ergogenic aid is a substance or procedure taken to enhance performance physically or physiologically. As mentioned above, bicarbonate is the ergogenic aid we're examining in our experiment. When subject to exercise, our bodies burn adenosine triphosphate as a primary fuel source. As exercise continues and we transition into the glycolytic pathway for energy production, we encounter byproducts leading to acidosis. To prolong the acidity levels rising too quickly and affecting exercise, bicarbonate, or commonly known as bicarb, begins to buffer. It specifically buffers hydrogen ions from combining with pyruvate and increasing blood lactate. We're not the first group to experiment with the effects of bicarb. Lind and colleagues looked at 200-meter freestyle swimmers. Ingestion of bicarb over a 30-minute period, 90 minutes before swimming, was what they examined. They found that this had a positive effect on times. Swimming, however, is not the only sport testing bicarb. Bishop and colleagues experimented with sprinters, specifically repeat sprint ability. They found that bicarb successfully buffered the hydrogen ions, increasing power output of the athletes. We hypothesized that administering an intervention of sodium bicarbonate supplementation prior to a controlled trial of multiple high-intensity intervals of running on a treadmill will improve performance in specific areas in contrast to the placebo trial. These areas are increased power output, extended time until exhaustion, reduced perceived fatigue and discomfort, and improved high-intensity interval training performance. More specifically, we expect the intervention to influence the buffering against the buildup of lactic acid in the participants' subjected muscles that are used for the high-intensity exercise. Within our experiment, we had one male aged 24 years old complete the test. He weighed 70 kilos and stood at 188 centimeters tall. Prior exercise history had him being active in external middle distance running. Research informed that a randomized double-blind crossover design would be best for unbiased data collection. Two trials were completed from this. A week apart, a placebo and intervention were undertaken with hopes rest in between would limit physical carryover effects. The trial order and ergogenic aid were both blinded in hopes to further reduce bias. During both tests, the subject 2 hours prior to beginning the trials had 4 dosages in 4 intervals of 15 minutes. Dosages were either sodium bicarbonate at 0.3 grams per kilo of body weight or the placebo of salt at 0.3 kilos per body weight, mixed with water and lime cordial. High carbohydrate food sources were also available to the subject during this time. The test was completed on a treadmill, with the experiment beginning with a 5-minute warm-up and progressing into intervals of 30 seconds on and 30 seconds off. This was repeated until max heart rate was reached or voluntary stop was requested. Blood pressure, blood lactate, heart rate, and RPE were all used throughout the test to collect experimental data. Blood pressure was taken initially prior to beginning the test. From there, heart rate monitor was fixed to the subject and connected to an adjoining watch to relay data. Blood lactate was taken prior and at every third interval throughout the test by taking blood samples from the subject's finger with a lactate measuring device. An RPE sheet, or rate of perceived exertion, was often referred to through the experiment for subjective heart rate readings. Now moving on to results. So we have our 3 figures in front of us. Figure 1 looks at our intervention or sodium bicarbonate heart rate results. The middle table looks at our blood lactate with bicarb being in blue and the placebo in red. And then finally the last figure looks at our placebo heart rate. From these trials, we found that the subject was able to regulate and increase their overall endurance to a higher standard while delaying the onset of fatigue at a more efficient rate per interval. This allowed for greater overall endurance performance, which supports the areas highlighted in the hypothesis. The intervention trial data demonstrated improved regulation and a decreased rate of lactic acid buildup in the subject. This can be seen visually through Figure 2, as it indicates the placebo's trial climb at a steeper rate per interval due to the missing presence of sodium bicarbonate in the subject system. This improved regulation and decreased rate can be seen as a translation to better overall endurance performance because of the potential ergogenic effect and enhancements sodium bicarbonate creates. Grigric and colleagues found that sodium bicarbonate elicited similar effects in comparable activities such as high-intensity intermittent running and other muscular endurance activities. The peak magnitude of the improved regulation and tolerance can be highlighted in the interventional trial. Figure 1 shows a continued trend of control and well-managed regulation of heart rate, and this tends to also correlate with the data from Figure 1 for blood lactate levels for the intervention. Price and Simmons and Krostrup and colleagues both found that all their patients, all participants, buffering capabilities had been enhanced for high-intensity intermittent exercise with sodium bicarbonate. Pert and colleagues also suggest that bicarbonate helps regulate and reduce lactic acid buildup. In summary, this study revealed that sodium bicarbonate supplementation had positive implications on high-intensity interval training exercise performance. From our results, we can state that we observed an increase in high-intensity interval training performance, an increased power output, extended time until exhaustion, and reduced perceived fatigue and discomfort, thus proving our hypothesis. The applications of bicarb supplementation suggest it can be fully optimized for sports that require high-intensity intermittent running. The positive effects displayed by the subject in the intervention trial highlight bicarb's potential to enhance anaerobic power, anaerobic capacity, and lactic acid buffering capacities for athletes. It's also worth mentioning it's cost-effective and very easy to access, which only strengthens its use. Thank you.